Welcome to Lesson 1.5, Should Do. In this unit, we've been studying quadratic equations by square rooting. We've also practiced using a graphing calculator to solve quadratic equations. In this assignment, we're going to combine those two skills. The problems that we work with in this section have to do with projectile motion. Typically in a math book, they'll provide you with the equation, but then give you no background to where the equation comes from. So let's start with giving you a little bit of background. If you were studying physics, you would learn projectile motion kinematic equations, and this is one of them. X is equal to x naught plus v naught t plus 1/2 at squared. The letter A for projectile is the force of gravity on an object. In this case, it would be 32 feet per second squared because most of our problems today are in feet per second squared. If something is dropped, then there's no initial starting velocity. All right, so if we looked at this equation up here, this would represent, the x would represent distance traveled. The x naught would represent the distance that you were when you started. V naught would be the velocity that you started at. So that's what the naught means, or the zero. 1/2 a is acceleration. And as I said, acceleration is force of gravity on an object. T squared. Okay, let's take a look at the first problem, first example. Get this to slide down. When an object is dropped, its speed continually increases and therefore its height above the ground decreases at a faster and faster rate. The height and feet of an object in t seconds is dropped after can be modeled by the function h. Now in this case, they're saying h is the height, equals negative 16t. Well, remember up here when we talked about the fact that acceleration towards the Earth is 32 feet per second, but it's 1/2 a. So what's 1/2 of 32? It's 16. And that negative sign is telling us that it's going down. So it's accelerating toward the Earth at 32 feet per second squared. H naught is its starting height. So H naught is the object's initial height. This model assumes that the force of air resistance on the object is negligible. Also, the model works only on Earth, so think about that. For planets with stronger or weaker gravity, different models would be used. So even on different places on Earth, the gravitational constant, it can be different. If I was on Mount Everest, the gravitational constant would be something different than 32 feet per second squared. But typically we just assume that we go with 32 feet per second squared. Okay, so here's our example. Modeling the following object's height with a quadratic function. A stuntman working on a movie set is to fall out of a window 100 feet above the ground. For the stuntman's safety, an air cushion 36 feet wide by 30 feet long by 9 feet high is positioned on the ground below the window. For how many seconds will the stuntman fall before he reaches the cushion? And then the second part of the question is, a movie camera operating at a speed of 24 frames per second records the stuntman's fall. How many frames of film did the stuntman film before falling? Okay, so take a look at the solution. The stuntman's initial height is h naught. So in that equation that we were looking at before, h naught is his initial height, and we plug it in here. Since the top of the cushion is 9 feet above the ground, you can determine how long it will take the stuntman to reach the cushion by finding the value of t, for which h is 9. H is the height that he's going to end up at. So he's going to be 9 feet above the ground because he's going to hit a cushion first. So you're filling in 9 feet for h. There's two methods to do this. One is to make a table of values. So you would put this equation into your graphing calculator and then look when he would reach a height of 9. So you can see what's going on here. He's reaching a height of 9 somewhere between 2 seconds and 3 seconds. And you can zero in on that by looking for the value on your graphing calculator. Method 2, we solve using a quadratic equation. So this first method up here, you can use your graphing calculator to find the exact value. Right now, you know how to use it by just looking at it and estimating. Here, we're going to solve exactly. Solve the quadratic equation. H is equal to 16t squared plus 100. Again, we're substituting in 9 because that's the height he's going to reach when he hits the pillow. Now we're solving the equation, and you know how to solve a quadratic equation because you've done that over the last few days. And we're down here coming up with the positive square root, and t is equal to 2.4 seconds. So it takes about 2.4 seconds to reach the cushion. And you can see, just looking at the table, it's going to be somewhere between 2 and 3 here. All right. Second part of that, number of frames of film that shows the stuntman falling is given by the product of, if he's falling for 2.4 seconds and they're filming at 24 frames per 1 second, then we just multiply and we get about 57 frames. Okay, so this is your example to go by. So this is a setup that you're going to use to solve the equations that you have on the assignment that you're given. If you have any questions, contact me, and good luck.